Good day and welcome to Global Kids Academy online classes. And today I'll be taking you the topic physics under the topic linear momentum. Hope you're happy to see me. Happy to meet you at home. How has been the break? Hope you're staying safe. My name is Mr. Dandy Ambrose. At the end of this lesson, I expect all of you to be able to explain the concept of linear momentum, state and explain the principle of conservation of momentum, list the types of collision, which includes elastic collision and inelastic collision, as well as solve simple questions involving conservation of linear momentum. And the principle of conservation of linear momentum is an important concept when dealing with problems that involve particle in collision or explosive events such as firing of a gun. Other particles that are involved in collision could include the collision of two balls or collision of particles when they gain enough of kinetic energy. Now, what is the statement of this principle? The principle states that in any system of colliding objects, the total momentum of the system before collision is equal to the total momentum of the system after collision, provided there is no external force acting on the system. The condition here states that there shouldn't be any external force acting on the system. This implies that the principle only holds true if the two bodies are the only bodies that exert forces on each other. Now, from the principle, we will see that before collision, you have two bodies, mass m1 with initial velocity u1, coming together with another body of mass m2, initial velocity u2. When they collide together, the momentum of the two bodies before collision will be the same with that of the two bodies after collision, with their velocity now v1 and v2, where we define m1 as the mass of the first body, m2 as the mass of the second body, u1 is the initial velocity of the first body, u2 is the initial velocity of the second body, v1 is the final velocity of the first body after collision, and v2 is the final velocity of the second body after collision. Hope you are following up. Now, what is linear momentum? Linear momentum is defined as the product of a system mass multiplied by its velocity. In symbol, linear momentum is expressed as P is equals to mv, where P is the momentum, m is the mass of the body, and v is the velocity of the body. Now, when you observe, let's observe on your screen, we have a moving truck of mass 150 kg moving with a velocity of 20 meters per second. Now, the momentum of this body will now be the mass of the body multiplied by the velocity of the body. And in this case, we have 1500 kg multiplied by 20 meters per second. This will give us 30,000 kilogram meters per second. That is the SI unit for linear momentum. We already define m as the mass of the body and v as the velocity of the body. Now, let's look quickly at what is a collision. A collision is the event in which two or more bodies exert forces on each other in about a relatively short time. And we have two types of collision. The first type of collision is the elastic collision. And in an elastic collision, when two bodies come together, they exert forces on each other in a relatively short time and move apart with different velocity after collision. The most important point to note on elastic collision is the fact that the two bodies does not stick together after collision. Now, if you observe this, you look at it, you have the basketball which have mass of m1 and velocity u1, which is initial velocity, the football with mass m2 and initial velocity u2, coming together to produce mass m1 final velocity v1 and mass m2 final velocity v2, that is after the collision. Now I want us to note that in elastic collision the following points are very important. 1, the colliding bodies does not stick together. 2, the relative velocity of the body is unchanged. And 3, there is either a reverse in the direction in which they were coming from, or the body continue to move in the same direction. Now I want us to note 3 different situations that may arise here. The first situation may be that after collision, the two bodies may reverse direction and move apart. The second case is either after collision, the two bodies will continue to move together in the same direction. This implies that the body behind that collides with the body in front must have a higher velocity than the body in front, and that is the only situation in which the two bodies will collide together. And the last situation is the situation where a moving body collides with a stationary body, or a body that is not moving, and there is the chances that the stationary body will move in the direction of the moving body, since the force is exerted behind the stationary body, and you know that force is a vector quantity. It implies that they have what? Magnitude and direction. Thank you. Let's continue quickly. The second type of collision is what we call inelastic collision. And in inelastic collision, the two bodies after colliding stick together and move towards one direction with uniform velocity. Now observe the truck on your screen with mass m1, initial velocity u1, and the little car by the other side with mass m2, initial velocity u2. That is before collision. After collision, those two bodies stick together and move in the same direction with a uniform velocity v. But the mass of the body now will be the combined mass of the truck and that of the small car, which is m1 plus m2. Now I want you to observe that in elastic collision the following points are very important. 1, the colliding bodies stick together after collision. The kinetic energy is decreased. Quickly, let's explain why the energy is decreased. Because the conservation of energy is neither created nor destroyed. So why is the energy decreased? Part of the energy is converted to heat and sound. When you hear the car collide together, you have a banging sound, and you hear there's an emission of heat. That is, the kinetic energy has been converted to heat and sound. The third one is the momentum is still conserved. Now let's quickly look at calculation involving elastic collision. In our next class, we'll be looking at calculation involving inelastic collision, but for this class we only focus on elastic collision. Quickly, the first thing that should come to your mind when we talk of elastic collision, you should know that it's a collision in which the body does not stick together after collision. Then I said that you should recall that in elastic collision the body does not stick together and the relative velocity of the two bodies remain unchanged in magnitude but reversed in direction. Therefore, mass of body 1, initial velocity of body 1, and mass of body 2, initial velocity of body 2 will produce the same momentum before collision with that of the two bodies after collision, m1 v1 and m2 v2. Now, because of the conservation of linear momentum, we say that momentum is conserved before and after. We have m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2, where m1 u1 plus m2 u2 is the total momentum before collision, and m1 v1 plus m2 v2 is the total momentum after collision. I hope you are following carefully. Now let's go ahead on this topic. Let's take an example quickly. A ball P of mass 0.50 kg and velocity 10 meters per second collides with a stationary ball Q of mass 0.30 kg. After the collision, ball P continues to move in the same direction at 3 meters per second. What is the velocity of ball Q? Now, an interesting part of this question is all the parameters has been given in their SI units. I want you to know that whenever any of these parameters is not given in their SI unit, we first convert them to their SI unit before going ahead with your solution. Now, if we illustrate this with the diagrams below, you see P, which is the mass of the first body, 0.5, U, which is U1, which is the velocity of the first body, 10 meters per second. U2 is the velocity of the second body, which is 0, because the body is stationary, therefore it doesn't have velocity, and M2, which is the mass of the second body, which is 0.3 kilogram. After collision, V1 has reduced velocity from, the ball 1 has reduced its velocity from 10 meters per second to 3 meters per second. And we are now to look at the velocity in which U2, that is the mass of Q, will now obtain. Now, from conservation, M1 V1 plus M2 U2 is equals to M1 V1 plus M2 V2. And the data has already been given as you are seeing on your screen. Now we quickly go into substitution into the formula. But when we want to substitute into the formula, we are going to work with collision before and collision after. Now before collision, you have M1 U1 plus M2 U2. Substituting this will give you 0.5 times 10 plus 0.3 times 0. And this will give you 5 plus 0. That is before collision. After collision, you are going to have 0.5 times 3 plus 0.3 times V2. When you summarize that, you have 1.3 plus 0.3 V2. When you simplify further and linking it together from the principle of linear momentum, you have that the total momentum before collision is the same with the total momentum after collision. So equating the two together, you have 5 plus 0 is equals to 1.5 plus 0.3 V2. Collecting like things, you have 5 minus 1.5 is equals to 0.3 V2. When you further simplify, you have 3.5 is equals to 0.3 V2. When we divide both sides by 0.3, you have 0.3, we cancel 0.3, you are left with V2. At 0.3, we cancel 3.5, that will go 11.67. Therefore, your V2 is equal to 11.67 meters per second. Is that pretty simple? I guess yes. I guess you are enjoying your lesson so far. Now let's take simple assignment and interact with it at home. Assignment number 1. A 3 kg ball traveling to the right with velocity 4.0 meters per second collides head-on with a 6 kg ball traveling with velocity of 8 meters per second to the left. After the collision, the 6 kg ball continues to move in the left with velocity 3 meters per second. What is the final velocity of the 3 kg ball? Pretty simple. Let me see how you try it out. Let's take question number 2. On a smooth surface, a soft 100-gram ball A at the velocity of 10 meters per second collides elastically with another 200-gram ball B with a velocity of 5 meters per second. The velocities of the two balls are in the same direction. After collision, ball A and B keep moving in the same direction at velocity 6 meters per second and V2 respectively. Calculate the final velocity of the second ball. That is also quite simple. Now recall that the masses of those bodies, 100-gram ball and 200-gram ball, are not given in their SI unit. The first thing you have to do is you have to convert 100-gram and 200-gram to kilogram, which is the SI unit for mass. Do that and submit to the WhatsApp number displayed on your screen. I hope you have a good time with me on this lesson. Till I come your way next time, I remain your teacher, Sir Ambrose Dangi. Thank you and enjoy your break. Bye bye.